How do we determine the Lewis dot structure for ionic compounds? Let's try for magnesium nitride. So first, magnesium nitride, from the name itself, it is composed of magnesium and nitrogen. So let's check this periodic table and look for magnesium and nitrogen. So where are they? Alright, so magnesium and nitrogen are both representative elements, and in terms of groups, magnesium is in group 2, nitrogen is in group 5. So this grouping kind of tells us the valence electrons of each of these elements. So for magnesium, it has 2 valence electrons, and for nitrogen, it has 5 valence electrons. So in terms of naming, first, magnesium and nitrogen, if we combine magnesium and nitrogen, they would be magnesium nitride. But how is that name derived? So for naming binary compounds of metal and non-metal, we take the name of the metal as is, and then for nitrogen, we keep nit or something, and then add the suffix IDE. So magnesium nitride. If it is the combination between magnesium and oxygen, is going to be magnesium ox IDE, oxide. Right, so the name is magnesium nitride if we combine magnesium and nitrogen. Again, the group numbers here tells us the valence electrons for each of these elements. So for magnesium, its atomic number is 12 number of protons and 12 electrons. Although it has 12 electrons, only 2 of those 12 electrons are involved in bonding, or they are called valence electrons. For nitrogen, nitrogen has 7 electrons, and only 5 of those are valence electrons, or involved in bonding. So the rest of those electrons that are inside are called core electrons. Right, so the name of the compound is magnesium nitride, magnesium and nitrogen. So these are their valence electrons. So here, nitrogen will take the electrons of magnesium. Why? Because, as you can see here, nitrogen only needs 3 electrons to become like neon. Magnesium, if it gives out its 2 electrons, it will become like neon. So the goal of this 2 is to become like neon because it's the nearest noble gas. Alright, so to become like neon, this is what will happen. Magnesium will give its electron here and here. So this one is like neon already. Since it's lost 2 electrons, it has here a net positive charge of 2 because there's more protons than electrons now for this magnesium, but we'll write it later. Right, so this nitrogen still needs 1 electron to become like neon. So where will it get that electron? It will get that electron from another magnesium. Right, so 1 magnesium here will provide that 1 electron to fulfill the wish of this nitrogen. So we have here a magnesium with a positive charge of 1. So where will it give its 1 electron? To another nitrogen. So we'll add 1 more nitrogen here. Right, so this 2 magnesium lost 2 electrons, so both of them has 2 plus charge because there's more proton. So this one needs 2 more. Where will it get 2 more electrons? To another magnesium. So let's give. So again, so for magnesium 2 plus, each of these 3. For nitrogen 3 minus for each of these 2. Again, it means that there's more proton here, and again it means that there's more electrons than number of protons here. So one way to deal with this is to apply the crisscross method, wherein group 2 elements usually lose 2 electrons and group 5 elements usually gain 3 electrons. So you put here a superscript of 2 plus for this metal and 3 minus for this non-metal, and transpose it here. The superscript will become a subscript. This superscript will become a subscript, so that we can derive its chemical formula Mg3 and 2 because we use 3 magnesium and 2 nitrogen. So what is the Lewis dot structure for magnesium nitride? Take note that we use 3 of this 2 plus magnesium and 2 of this 3 minus nitrogen, and just place here a coefficient of how many magnesium that we use, and also coefficient for the number of nitrogen that we use. And take note that they have here a net charge for losing and then for gaining electrons. So there you go. So that is the Representation of Lewis dot structure for ionic compounds. Thank you for watching.